Hello, Gaz here, and this video that we recorded as part of my lightning session on 29th of April, and we had a couple of engineers joining as well, which was on maven.com. And we went through 6 questions that it allows you to defend your system design. And if you ever within interview, or if you actually go through explaining your system design to another engineer, these are the questions that allows you to explain a bit better and introduce yourself as an expert. So this is the video. Hopefully you enjoy it, and I've got other lightning sessions as well which you can join. Also have a cohort, a course that is open now to registration, and make sure you subscribe to these videos as well. So hopefully I'll see you in the next video. Okay, so I think it's recording as well. So many people signed up. I think it was like 40 people, but because it's free, so I'm not sure if everyone's going to show up. That's definitely a different question, right? So what I want to talk about, I think we've got only like 30 minutes as well. So the idea here is to share my screen. Let's see if I can manage to do that. Where is it? Yep. I can probably just share my desktop, probably. Oh no, I can actually share my Chrome. Okay. Nice. This is the first lighting session through Maven. I've organized the other two as well, but this one is going to be more around the software architecture, which is probably more involved in. Feel free to ask questions. I'm not sure if I see chat actually, so if you ever ask questions, that's going to be tricky. Let me see if I can see the chat as well. Yeah, okay, I can see it now. Yeah, first experience with Maven, and I'm going to go through the architecture. Most of the time throughout my work, I'm actually doing some sort of like planning for architecture. So I've got a good kind of view about what is a good architecture, what is a good software architecture, or you could also say what is a good system design. And it's really common. I think the story of this lighting session starts with you make these decisions, and then a month from now, someone's going to ask you, why did you choose this? So if you're really good, you have the ADRs, you have the architectural decisions written, and you have it, you can actually point it to that architecture. Or if it's like an interview, you don't have that architecture or ADR, so you can't just show it because this is like showing the company's confluence or something. But they're going to ask you about, okay, why did you choose this database, or why did you choose the other technology? And answering this question, this is a topic that we want to go through, which is, I summarize it as 6 questions. So let me share my TL drawer here. So the idea is, for example, this is the first scenario. If your team is building a new payment system, and for any reason you've chosen Postgres over DynamoDB, and then you're going to defend it. So this is an interview. I think this is really common in interviews. And they say, okay, what have you done in your previous job? And I'm like, okay, so we developed the procurement, or we developed this payment system. And they're going to dig a bit deeper through what's happening, or what the architecture you went through. And then this is not important for them, because the next question is going to be about, okay, so you chose MongoDB because, and that's the part you might be struggling, because you just chose it maybe because it was something from the company, or like our company started to enforce Postgres over anything else. But some of the times it just doesn't make sense to go with Postgres. So the other thing is really important to notice is there's always a trade-off. If you choose the first option, you definitely lose some of the benefits of the second option. So it's always a trade-off. So if there is never a good best choice that you could say this is the best choice ever. It's always you losing something. So that's also is really important. So you should be aware about, okay, by choosing this, what am I going to lose? So this is basic understanding of architecture. So this is the first scenario. So why did we choose Postgres? And that was a payment system. And you might say, oh, obviously, right? Because it was a structured data. So this is, you can go through answering that question. You could say, what problems were we actually solving? So for example, you could say, oh, so by choosing a Postgres, we wanted to solve this problem. We wanted to actually say, oh, the consistency of data is really important for us, right? So the consistency was really key for you that you wanted to have. And then the structure, you wanted to have a good schema definition with your data. So this is probably something you can start defining to say that was a reason or that was a problem we wanted to solve, and it was a consistency because it was a payment system, so it was really important for me to have this structured data, and I wanted to actually have validations and everything, but at the same time I wanted to be ACID as well. So DynamoDB couldn't actually give me this consistency over my transactions and my data. So then we went with Postgres. So the second question you want to go through is what did we consider and reject, right? So you want to say, in terms of choosing Postgres, what did we consider? We wanted to have like tons of data. So for example, we have massive number of data. So you might say we had around 10K TPM, like transactions per second. Sometimes they use per second, so you can say TPS, sorry, or TPM, transaction per minute. And then because of that, this is something we considered, and we wanted to make sure our systems can actually manage these number of transactions per second. And it was important for us to make sure our database respects the atomicity of each transaction. So this is something you would say, oh, we considered this load that needs to go through the system. And the other thing is, okay, so we considered this, right? But what if my data gets over, who knows, 100 gigabytes? Then we also considered with DynamoDB, because we can horizontally scale. So this is a difference between, probably I need to explain it a bit better as well. So with the NoSQLs, you can horizontally scale, so you can just easily add another service. But with SQL databases or Postgres, you can't really do horizontally. So this is, for example, SQL databases. You have to either vertically, so that means more RAM or more CPU or more storage. And at the same time, if you go further than that, and then you're like, oh no, I actually have to have two servers, you might say sharding, shard key, and you see already the complexity is way more, because now I have to actually explain it. What is my shard key, and how can I actually have two databases or two structured databases to be used as one, and then I know which query goes to which one of these databases. So what are we optimizing for? One of the things is we want to have a good velocity within the team. And if I go with the Postgres, my team knows Postgres better than DynamoDB. So that's also something, say, my team can actually deliver it way faster with Postgres. So the learning curve for DynamoDB is not there as well. So these are all the arguments. So you can see, if I want to explain to someone, I can say, oh, so my team knew how to work with Postgres. I knew exactly I'm going to have 10K transaction per second. The consistency of data was really important for me. And I knew I had to have ACID or respect ACID or atomicity of different. We could go through definitions as well. And then I've got like these trade-offs that if my data actually goes more than this storage, I have to use a shard key. So what are we giving up? So what we're giving up is we lose a bit of simplicity. So you're giving up this simplicity, this no structured database that maybe it was allowing you to develop something faster, but at the same time, you go with Postgres, so you want to restrict it, you want to have the better database. So you're losing simplicity, and you also know within scaling, you're going to have like scaling easily. That's something you're going to lose as well. So just by mentioning these two, your interviewer or whoever you're talking to, they know that you know what you're talking about and you understand the trade-offs. And then under what conditions would we choose differently? So this is something I think you want to know in advance to say, okay, so if my team knew DynamoDB better than Postgres, that was something maybe I was considering it. So if DynamoDB was something more familiar with the business and they didn't know how to use Postgres, maybe that was something, a game changer for me. The other thing was, okay, so no, I actually didn't really care about the asset of these payments, and scaling horizontally was more important for me. So I don't have a lot of records that need to go and find something within this database. Or so you could say if my, for example, schema definition wasn't as defined, so it wasn't, schema wasn't really defined. I wanted to constantly update it for the new transactions, or it was like a messaging. So you could say, oh, maybe in that case, I would choose DynamoDB. So if you know the answer to that question, it helps you out as well. And then you want to say, how would we know if we got it wrong? So we go with this database and we had these many requests coming to our system, and we see we can't scale it properly. We don't have a good shard key. Our infrastructure doesn't support it. At the same time, we see the number of issues, or our database can't handle these many databases. Then these are the questions you want to kind of review again, say, oh, we actually put this much load to our system and our database can't handle it. So I guess the classic example for this would be, businesses went with SQL Server, and then within few years down the line, they understand SQL Server's scaling is quite costly. So they can't really scale it without spending too much money. But if you go something with Postgres, then they have an easier life. Or we have alternatively some companies, they went with MongoDB, and after 3 or 4 years, they found out because they don't have these asset definitions, they don't have these schemas, and their structure of the data is not really solid. And then they find out MongoDB actually made it more difficult for them. So you want to understand after a month, if I had these issues, to say, I chose Postgres, but scaling is becoming a mess, right? So for any reason, I don't know how to scale it, or my database can't handle these many requests. Or, for example, you might say our schema is not as defined as what we thought, right? So this is the way you want to explain your decisions. So keep that in mind. When someone asks you, why did you choose this? You want to go to say, oh, so I know the benefits. I know the downsides of making this decision. I know we could have gone to the other direction if we didn't have these variables to our system. And I know by choosing this, I lost this, for example, simplicity or scaling. And then you want to convince the other people, say, I made actually a good decision. So the other one that I want to go through is, this is the second scenario. If you could contribute if you wanted to as well. And this is about your team needs to decide how to handle async communication between two services. I guess I think I've asked these questions in many interviews as well. So this is a classic question. You go to the interview, it's a system design interview, and you're like, okay, so now I have two services because you thought having two services is better. Sometimes if you don't have services or you don't define different services into your system design interview, it's actually better for you, because the moment you go to services, then you open up a lot of other questions as well. And then you want to say, no, I actually have two services. That one of them is, for example, you would say payment, and another one is actually like order. And I want to say we had direct HTTP calls with retries. That was one of our questions. So you say, I wanted, after the order, I wanted to actually get a transaction and pay it. So do we have APIs, or we go with the message queue? That kind of means that instead of having this, you want to have something in the middle to say, no, actually push events to this Kafka, and then I push it to the payment. So that's the second question, right? So then for this case, we went with option B because we wanted to, I think now the question is, why did we do that? And I think the most important one is, what are we optimizing for if we go with option B? And I think what could be the reason we chose to have a message queue between these two, for example, order and payment, and we didn't go with API. So what are we really optimizing for? Yeah, I'm not sure if anyone wants to participate, but this is a classic question, right? I'll give you a few seconds to think about as well. So I think the next question that we want to talk about is, what are we giving up? Meaning, by choosing B, meaning using the queue, what happens and why, what we lose. So I guess the first one is quite easy. What problem we are actually solving? I think we want to we have the communication between two services, and these two services want to get some sort of data, or they want to submit the payment or whatever it is. But we are actually solving the number of requests or number of transactions that we have with the system. So any company wants to pay 10,000 users at the same time, and the order comes through 10,000, just pay everyone, and then how would you do it? So with this case, I guess a direct call might actually work. You could say, oh, for every request, wait, send the request, get the response, and then go to the second one. So that could be first option. The second option was, oh no, let's just introduce a message queue. So you could literally do it with both cases. So it's not like one solution is the ultimate answer here. It's always, as I said, it's always trade-offs. So I guess that's the trick with the interviews as well. They ask you, why did you choose this? And if you say, oh, that was actually best choice, then they know you don't understand trade-offs with the decisions, and actually everything can work, but you lose one thing over another. We wanted to go this, and then what problems were we actually solving? I guess 10,000 requests we wanted to go through. We wanted to make sure all of these 10,000s, regardless, they would be processed one time. And if anything happens, we have a retry mechanism as well. And our system actually, it wants to be optimized for this level of, for example, sending or something, or sending different messages. So this is maybe an architectural decision for the company to say messages or event driven is actually more important. So when I want to explain it, I want to say, what are we optimizing for? We want to optimize for better boundaries. So that's something I get with the event driven, because these systems don't have to rely on each other. They just push an event, the other service doesn't really care about it. So we have better boundaries, better domain definition, and independent teams that they want to work on these features. The other thing that we wanted to probably optimize is we wanted to optimize for cons or delivery and retry mechanism. Okay, so we are optimizing for that. The other thing is, okay, what are we giving up? So this is a key part. By doing that, we actually lose the request getting answer right away. So we have to have eventual consistency. That's the term for it. It means that because of each request, then we have to wait the processing time between the Kafka and the payment. So because of this eventual consistency that we get from the messaging queues, we have to say, okay, so if someone clicked on pay and then we wanted to pay them, because we have these events being fired, then we have to introduce new states here. So we have to introduce being or processing state. And then the processing state might even say we are processing 10 out of 1,000. So then you have to get this data to UI to say we have this processing time. And because we have these events, then within the payment system, you have to introduce another complexity of having, for example, a consumer that listens when the payments are done. I know how to update the order to say 10,000s are actually done. So you also giving up the simplicity of the first option. So the how you couldn't say it's actually like more complex, but it's not as simple, because with Kafka, then you wanted to have a DLQ, you wanted to have a retry, and this sort of stuff that kind of just makes your implementation a bit more complex. So you might get better boundaries, you have better domain definition, you can scale better as well. So that's something with the event-driven designs, but you lose a bit of consistency. So it would be eventual. So you have to wait, you have to introduce a few more states, you have to update the UI, and then you also need to implement like DLQ. You have to know how to retry them. You might have a dead letter, you might have a poison letter. So there's a lot of stuff that comes with the queue. And then you also need to maintain the queue, because that would be another infrastructure that you need to have is if you're using AWS or anything else. So this is pretty much the lightning that I wanted to go through. The next lightning I organized to have your system design answer is right, but unconvincing. So this is probably something with the system designs that you explain something, but you think it's not convincing my team members to let's just do this. And the next one would be around the ADRs that gets you promoted, because I think with AI, the whole idea of how we write ADRs and how we do everything is changed. I'm going to explain to you what a good ADR looks like and how you can actually write better ADRs. So that's going to be something that I'll show you how I do it and how you can actually improve it with AI as well. And that would be probably the next lightning sessions. I also have the cohort of I want to explain, or we go through the system design and everything. So if you were interested to do the cohort as well, just let me know. So you can absolutely reach out to me in Gazar.dev if you have any questions. I tend to post some articles here as well, but hopefully you enjoyed this lightning session. So I guess we can just finish it here. Anyone has any questions? Okay. Thank you, everyone. I hope you enjoyed the session. I'll see you in the next one. Thank you.
Thanks.